What's up, Inspired Vision? This is Pre-Cal Week 20 Tuesday. Alright, it is time to learn some math. But wait, that doesn't mean learn. That's a piece of cheese. That's because today it's going to be easy to learn. Easy, easy, cheesy, cheesy. If you like this line, shout out to Miguel. Alright, we have a notebook check on Friday. Do not be caught in the mousetrap. Be ready for Friday. I am looking for 11 things. Plus, if you have your review that I'm giving you tomorrow finished when I do your notebook check, I'm giving you bonus. Okay, today we're going to learn about simplifying factorial expressions, which is a continuation from yesterday. This is, after today, I'm not teaching you anything new for this week. We're just reviewing to get ready for the test on Friday, because the test on Friday is over the last 3 weeks of material. So the first thing I need you to write down is this. Write this down in your notes. In order to do this problem, we are going to think back from yesterday. Yesterday, we did, in order to write this factorial, 6 factorial, we wrote it as 6 times 5 times 4 times 3 times 2 times 1. And then we put that over the bottom factorial, which is 3 times 2 times 1. Then we reduced. So all we said we had to do left was multiply 6 times 5 times 4. Which is 120. Now, let me teach you something a little bit new that will help you for today. Instead of writing it all out like this, we can write it out like this. 6 times 5 times 4. And notice we have a 3 factorial on the bottom. So I'm going to stop writing out 3 times 2 times 1 because we have a 3 factorial on the denominator. If we write it out like this, this is a little bit easier for us to simplify, so we don't have to write it all out, and it'll make it easier for the problems that we're doing today. Makes sense for everybody? Okay, next problem. This time we have 2 questions. We have 5 factorial times 3 and 5 factorial plus 4. Now, we can't use our little trick that I just showed you on these problems. These problems, we're going to have to write these out. But notice that here, in our first problem, we need to multiply. So you can either write it all out like this, or get your answer for 5 factorial and then multiply for your answer for 3 factorial. Gotta love the bell. Okay, so your answer for number 2 is 720. Hopefully you got that. And your answer for the second question on the screen this time we're gotta add our 2 factorials. And you should have 144. Okay? Alright, next. That was cheese, by the way, because that was easy. Alright, Alex, stop thinking about Clash of Clans. We have to do this question. In this question, we have 8 factorial divided by 2 factorial, and it's right next to each other next to 6 factorial. So in a way, this is multiplication. All right, ready? Oops. So the numerator, we have 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. We could write that all out, or we could use the new way of writing factorials, which would be saying 8 times 7 times, and then I notice there's 6 factorial on the bottom, so I'm going to write it as 6 factorial. That way, when I say 2 factorial, which is 2 times 1, I want to write this one out, and I don't want to write 6 factorial out because that just reduces. So all we have to do is multiply 8 times 7 in the top and divide it by 2 times 1, which is the same thing as saying divided by 2, which is 28. All right, no time for Clash of Clans right now. We have work to do. Here is number 4. These problems will expand your mind a little bit. I know, right? There's no numbers on the top. There's letters on the top too. It's okay. So n plus 5 factorial on the top divided by n plus 3 factorial on the bottom. And then we also have n plus 3 factorial on the top, n plus 2 factorial on the bottom. All right, so we have to use our rule here, which the rule yesterday was we did for factorials, it is n times n minus 1. And then we keep going. So we have to keep going down by 1. Okay, now since both of these are plus in number 4, I don't have to write this in. All I have to do is keep going down by 1. So I'm going to write n plus 5, and then if I go down by 1, then I'm going to write n plus 4. Does that make sense? All I did was go down by 1. Then the next one's going to be n plus 3. And I'm not going to keep going down by 1 because we're going to use our new trick that we learned, which is, since I already have this in the denominator, I'm not going to keep going down by 1. I'm just going to reduce. And that's it. That's my answer to number 4. All right, so let's apply the same trick to the second question on this slide. If I go down, write what I have in the numerator, and then go down by 1, going down a 1 from 3 will give me 2. And I'm not going to write n plus 1, which would be going down again. There's no need because I have n plus 2 in the denominator. Once you have the same thing in the numerator and denominator, you can reduce them. So this answer is just n plus 3. All right, that's it. Everybody ready for the second question? Or next question? All right, these are slightly different. It's the same thing, but slightly different. Notice that we have a positive number in the top and a negative number in the bottom. So we're going to apply the same rule. We're going to start with n plus 1, and we're going to go down by 1. I can give you a second to finish writing these down. All right, so in the top, we have n plus 1. Now if you go down from 1, having a positive 1, the only thing you're left with is an n, because then it would be n plus 0. Then after that, you would have n minus 1, because then you're going to your negatives. So that's what makes this slightly different from the last problem, is you have to represent that n. Now, n minus 1, I'm going to stop. I don't need to go to n minus 2, which would be the next one down, because I have n minus 1 in the denominator. And these cross out. So your final answer here you're looking for is n times n plus 1. You can rewrite it to put your n in front. You don't need to worry about distributing because you're going to see these answer choices on your homework. Okay, second problem on this slide. Again, we have a positive number on the top, a negative number on the bottom. So the top, we start with n plus 1. If we go down 1 from here, from positive 1, we're going to have our n. If we go down another 1, we're going to have n minus 1. And then we go down another 1, n minus 2. At this point, we can stop because we have n minus 2 in the denominator. And these reduce. So your final answer, you don't have to worry about putting this in any type of format. I guess I might put it as like this. But your homework should have some variation of these formats. It doesn't matter which one of these comes first, because you're multiplying, doesn't matter order. Okay. Next question. This problem we've already kind of done. We have 12 factorial divided by 7 factorial times 5 factorial. All right, remember how to do these? These are pretty cheese. That's because they're easy. So I am going to notice that this is my biggest number. Since it's the biggest number, I'm going to keep going down from 12 until I get to 7. So I'm going to say 12 times 11 times 10 times 9 times 8, and I'm going to stop at 7. The reason why I'm going to stop at 7 is because I know it's going to reduce with the 7 in the denominator. Now the 5 I need to write out because I can't reduce that with anything, because my 5 through 1 got reduced when I reduced to 7 factorials on both the top and the bottom. Okay, type that in your calculator real quick, and then we're finished. All right, your final answer should be 792. Okay, next. This question is for honors, but everybody's going to do it because it's not that hard. 12 people are entered into a race. If there's no ties, how many ways can the first 3 places come? Okay, so if you have 12 people in a race, you're going to represent that as 12 factorial. Remember, factorials are series that have to do with probability. That's the reason why we're doing this question, but it's not that bad. Now, if we have the 3 places, and we're asking how do the first way, different ways to represent the first 3 places, that means that we can subtract 12 by 3 to be 9. All we have to do to represent the different combinations of the 3 places is divide by 9 factorial, because we're going to reduce those. So if I have 12 factorial divided by 9 factorial, oops. I can write that as this. Well, 9 factorials cancel, and all you have left to do is multiply 12 times 11 times 10, which is 1320. These are different, the 3 different ways, because the 12 people entered a race, 1,320 different ways that the first 3 places can come. Okay? That's how we use factorials in word problems like this. Okay, next. This is going back to what we learned last week. All right, Emily, it's not time to think about Taylor Swift. We only have 2 questions left. So, we have a geometric sequence. We need to figure out, and remember, this S of 5 means the sum. So that means we have a finite geometric sequence, which means we're going to use this equation, A1 times 1 minus r to the n divided by 1 minus r. So our A1 is easy. Our A1 is the first term in the sequence, so that's going to be 6. The most important thing about geometric sequences is to find the pirate in the problem. We have to figure out what the r is. And for r, we do our second term divided by our first term. So that means we have negative 30 divided by 6. And that gives us negative 5. So our r in the problem is negative 5, and we can finish our equation. So the top is going to be 1 minus negative 5 to the 5th power divided by the bottom, which is 1 minus negative 5. All right. When we do these questions, we need to start by figuring out this. So type that in your calculator. And we get 3,126. Then we need to divide by the bottom, which is 1 minus negative 5. You can type that in your calculator, just put it in parentheses if you want to type all this in your calculator, or know that that is a 6, which you don't need to type in parentheses if you simplify it, which is 521. Now you multiply it by 6, which gives us what we started with, which is 3,126. That is the sum of the geometric sequence. Okay, next. Now we want the sum of the series. But if you notice, they didn't give us S5. They didn't tell us where to stop. They gave us ... In a second, I will ask you if that's infinite or finite geometric series. Okay, this is infinite. Since it's infinite, we have a different equation to use. Our equation to use here is A1, which stands for our first term, divided by 1 minus r. So again, for geometric, we have to find r first, which is our second term, divided by our first term. So we have negative 3/8 divided by negative 3 over 2. If you type this in your calculator, just make sure whenever you're doing fractions, you put it in parentheses. I'll give you a second to type this in your calculator, or I'll show you how to do this by hand. Okay, so we have -3/8. If you're doing this by hand, you're going to keep switch flips. So you're going to change it to multiplication and flip the reciprocal of your second one, which means your 3's cross out, and you can divide your 8 by 2 and divide your 2 by 2, so that crosses out to a 1, and this crosses out to be a 4. Both of these are negative, so no matter if you type this in your calculator or you're doing this by hand, you should have 1/4 is your R. Alright, we have everything to do to finish this problem, or everything we need to finish this problem. Our A1 is -3/2. Then our denominator is 1 minus 1/4. Just make sure if you're typing this in your calculator, use parentheses for both your numerator and your denominator that has 2 terms. Either way, your answer should be -2. So your your infinite geometric series sum is -2. Okay, last question. Here it is. This one's talking about the lottery. Now this question is for honors, but I think everybody can do it. So we have, we have a sequence of 6 numbers to correctly win. Your lowest number is 1, your highest number is 50, and you can only give them once per try. Or you can only use the same number once per try. Okay, I'm going to go through this kind of fast because it is for honors. Regular, you don't have to worry about it. It will be for bonus if you can get this right. So, since I'm only choosing between 50 numbers, we have 50 factorial. Then we're going to choose a sequence of 6 numbers correctly to win. So 50 minus 6 is 44. So we're going to divide it by 44 factorial. Now we would be finished with trying to figure out our probability with just this, except for it doesn't matter which order these 6 numbers come. So since it doesn't matter if you pick like lucky number 13 first or lucky number 13 second, or for you, Mary Angela, lucky number 21 first or second, that's going to increase our probability. So we're going to multiply by 44 probability and 6 factorial. That's how we're going to represent this. Now, I'm actually fine if you leave this as your answer, but if you want to put a number to this, here's how it's going to look. It's going to be 50 times 49 times 48 times 47, 46, 45, 44 factorial, because the 44 factorial will reduce with the denominator. We need to multiply all these together, and then we also need to multiply 6 times 5 times 4 times 3 times 2 times 1. This is our chances of winning the probability, or winning the lottery. It's going to be a huge number in your calculator. That's why it's using scientific notation. If you're typing this in, it'll say e to the 10th power. That means you move your decimal place 10 times over to the right. And then once you finish dividing by this, it gets out of scientific notation to say your chances of winning the lottery is this. Now, with the lottery, they always say your chances are written as a fraction because you can only pick it once out of this number. So this is your chance of winning the lottery for this question. All right, finally, I'm giving you homework today. If you can finish it with a 90 or higher for an extra incentive, and you turn it in before Friday's test, so that means tomorrow you turn it in, or Thursday, or before you have your test on Friday, I will give you 10 points on your test. That's a very good deal because, like I said, this week's Friday's test is only our second test for the 6 weeks, so it's going to be a big deal. Now, if you finish your homework but you don't get a 90, oops, I made a mistake on the slide. You make a 80 or higher, I'll give you 5 points. Now, what happens if you turn your homework in tomorrow but you make a 75? Well, I'll let you redo your homework assignment and keep trying as long as you turn it in before Friday's test if you want this bonus. All right, that's our lesson for today. I will talk to you guys tomorrow.